Day 433 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3440, reschedule meetings for maximum free time 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer event time denoting the duration of an event. You are also given two integer arrays start time and end time, each of length n. These represent the start and end times of n non-overlapping meetings that occur during the event between time t equals 0 and t equals event time, where the ith meeting occurs during the time start time of I and end time of I. You can reschedule at most one meeting by moving its start time while maintaining the same duration such that the meetings remain non-overlapping to maximize the longest continuous period of free time during the event. Return the maximum amount of free time possible after rearranging the meetings. Note that the meetings cannot be rescheduled to a time outside of the event time and they should remain non-overlapping. Note in this version, it is valid for the relative ordering of the meetings to change after rescheduling one meeting. All right, y'all. So it may sound a little bit confusing at first, so let's go ahead and check out these examples just to make sure that we're doing this problem correctly. Now, before we look at these examples, I would suggest you guys take a look at yesterday's problem where we did the first version of this problem, which was reschedule meetings for maximum free time 1. It'll give you some extra knowledge when we're completing this problem, and it will help you understand what's going on with this problem. So the first difference is we don't have a K in this problem, and we also are allowed to we are allowed to order the meetings to change after rescheduling one meeting, or we're allowed to move the relative order, we're allowed to change the relative ordering of the meetings to change after rescheduling one meeting, which we weren't allowed to do that yesterday. So with that being said, let's take a look at example 1. In example 1, we have our event time equals 5, start time equals an array of integers 1 and 3, end time equals an array of integers 2 and 5. The output is 2. Explanation says reschedule the meeting from 1 to 2 to 2 to 3. Leave no meetings during the time from 0 to 2. So let's break this down one step further just so we can make sure we completely understand what's going on. So we have our event time right here, which is 5. That means the event is going from 0. We could just call 0 noon or 12 o'clock noon to 5 o'clock p.m. Boom, that's the event time from 0 to 5. Then within the event time, we have meetings. So this green box represents a meeting. This gold box represents a meeting. Our first meeting starts at 1, right? And so that's the start time. Starts at 1. Then the end time for our first meeting is at 2. So our first meeting, these two indexes and start time and end time correspond to each other. This is what time the first meeting starts, and this at index 0 of start time, and at index 0 of end time, this is what time the meeting ends. So as you can see with this green box, meeting starts at 1, meeting ends at 2. Boom. Similarly with this in index 1 of start time, the meeting starts at 3, and meeting 1 of end time, or index 1 of end time, the meeting ends at 5. So that's this gold box, right? It starts at 3 and ends at 5. So these indexes correspond with each other in the start time of end time, letting us know what time the meeting starts and what time the meeting ends. What we want to do is we want to reschedule these meetings so that we can have the maximum amount of free time. So it says right here we can reschedule the meeting 1 and 2 to 2 and 3, leaving no meetings from the time 0 to 2. So just imagine we move this green box down 1 from, so instead of starting at 1, it starts at 2, and it still is only an hour. So from going from 1 to 2, taking up that hour, now we reschedule. So now this meeting goes from 2 to 3, taking up this hour, leaving all of this as free time. So now we have 0 to 2. That's 2 hours of free time. Thus our output is 2 because that's the maximum amount of free time that we will be able to achieve with these parameters right here, right? If we move this down then we'll have 2 hours of free time. We could move it this way and we'd still have 2 hours of free time, but either way, the maximum amount of free time that we can have is 2 hours of free time. So let's take a look at example 2, where it's a little different, because this is where we are allowed to change the relative ordering of the meetings can change after rescheduling one event, where yesterday we weren't allowed to do that, but today we can change the order of the meetings. So let's take a look at how that works. So in example 2, we have our event time equals 10, start time equals an array of integers 0, 7, and 9, end time equals an array of integers 1, 8, and 10, right? So it says, the explanation says, reschedule the meeting from 0 to 1 to 8 to 9, leaving no meetings during the time from 0 to 7. So once again, we have the same principles apply. Event time is 10, so the event is going from 0 to 10, or from noon to 10, right? Our first meeting would be from 0 to 1, or from noon to 1. We're trying to reschedule this meeting right here from noon to 1. We're trying to reschedule this meeting to 8 to 9, right? But because as you can see, this meeting is only an hour, and we have an hour of free time in between this meeting and this meeting. So instead of just coming to the event at noon because we have to make this early meeting, we could reschedule this early meeting and to be a later meeting to happen around 8 or 8 to 9, which would mean we don't have to show up to the event until 7 instead of showing up at the event at noon and having to wait from 1 to 7 with nothing to do. We could just reschedule this meeting to 8 to 9, and then we could show up at the event at 7, and we could leave the event at 10, because all of our meetings will happen right after each other, right? So if we reschedule this meeting from 0 to 1 to 8 and 9, now we have from 0 to 7, that's free time. We just opened up 7 hours of free time, and that's why our output is 7. So let's take a look at example 3, our final example before we get into the solution. So in example 3, we have our input event time equals 10, start time equals an array of integers 0, 3, 7, and 9, end time equals an array of integers 1, 4, 8, and 10. This time our output is 6. Explanation says, reschedule the meetings at 3 and 4 to 8 and 9, leaving no meetings during the time from 1 to 7. So in this case, we're going to move this meeting, right? So we can only move one meeting in this version of the problem. It says, where does it say? You can reschedule at most one meeting. So yesterday we could reschedule at most K meetings. Today we can only reschedule at most one meeting. And in this example, we're choosing to reschedule this meeting right here from 3 to 4. Similarly to this problem, we're going to move this 3 to 4 meeting to right here, 8 and 9, in between 8 and 9. So now that will open up all this free time from 1 to 7, and that will give us, right here, that'll give us 6 hours of free time. 1 to 7 will give us 6 hours of free time after we move this meeting to over here in this slot right here between 8 and 9. Boom. So let's take a look at example 4, where there is no free time, right? So in example 4, we have our input event time equals 5, start time equals an array of integers 0, 1, 2, 3, and 4, end time equals an array of integers 1, 2, 3, 4, and 5. Our output is 0. Explanation says there is no time during the meetings during the event not occupied by meetings. So as you can see, we have our first meeting goes from 0 to 1, or from noon to 1. Then we have another meeting that starts right after that goes from 1 to 2. Boom. Then we have a meeting that starts right after that goes from 2 to 3. Boom. And similar, we have a meeting right after that goes from 3 to 4. And then we have a meeting right after that goes from 4 to 5. And since our event time is 5, we can't go past 5 because the whole event is over at 5. So that means we have no free time, right? We have meetings from 0 all the way up until 5, or from noon to 5. Our schedule's booked. We have no wiggle room to reschedule meetings or anything. We just have to go to all the meetings. So with that being said, y'all, I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Now for this solution, the first thing we are going to do is we're going to declare constant. We'll say let n, capital N, we'll set that equal to start time dot count, and that's going to get us the length of start time. Then we're going to say if n equal 2 =, 0, then we're going to open up the brackets and we are going to return event time. Boom, because if there are no events, then the entire time is free. So then after we handle that, we're going to come right here and we're going to calculate the free time or the gaps between scheduled events. So we're going to declare a variable. We could call it gaps. We're going to say colon. It's going to be in then we're going to say square bracket is going to be an array of integers, and we're going to set that equal to, open up the square bracket, start time, square bracket 0 to start. So the first gap or the time before the first event starts. Then we're going to come underneath that and we're going to say for I in 1 ... up to capital N. We're going to open up the brackets, and the gap between the end of one event and the start of the next event, we're going to say gaps dot append, open up the parentheses, start time square bracket I. Come outside that square bracket, we're going to say minus end time square bracket I minus 1, just like that. Now the final gap or the time after the last event, we're going to handle that, we're going to come right here and we're going to say gaps dot append, open up the parentheses, event time minus end time square bracket capital N minus 1, just like that. Now we need to compute the prefix or the max array of gaps excluding the last gap. So to do that, we come underneath this, declare a variable we call it prefs, say colon, that's going to be an array of integers, so square bracket integers, and we're going to set that equal to square bracket gaps square bracket 0, just like that. Come outside or come underneath that, we're going to say for I in 1 ... up to, open up the parentheses, gaps dot count minus 1, open up the brackets, and we're going to keep track of the maximum gaps seen so far from the left by saying prefs dot append, open up the parentheses, max, open up the parentheses, prefs dot last, exclamation point, comma, gaps, square bracket I, just like that, y'all. Then we can come underneath this for loop, and we're going to compute the suffix max array of gaps excluding the first gap. So this time we're going to declare a variable called suff or sus. We're going to say colon, that's going to be an array of integers, and we're going to set that equal to square bracket gaps dot last and put the exclamation point. Boom. Then we come underneath that and we say for I in stride, open up the parentheses, from colon gaps dot count minus 2, comma 2 colon 0, comma by colon -1. Come over here, we're going to open up the brackets and we're going to keep track of the maximum gap seen so far from the right. So we're going to say suffs dot append, open up the parentheses, max, open up the parentheses, suffs dot last, exclamation point, comma, gaps, square bracket I, just like that. Then we come underneath this for loop and we say suffs dot reverse, and we're gonna put parentheses at the end. Then we're gonna come right here, we're gonna declare a variable called and, set that equal to 0, and that's going to store our final result or the final amount of free time we have, right? So this is going to store our output, and that's going to store our output. Boom. Then come underneath ands and we're going to say for I n 0 dot dot less than n, we're going to open up the brackets and we are going to say let slot equal n time square bracket I minus start time square bracket I, and that's the duration of the current event. Then we're going to come right here and we're going to say let L gap, we're going to set that equal to, sorry y'all, set that equal to gaps square bracket I, and that's the gap before the current event. Then we're going to say let R gap, we're going to set that equal to gaps square bracket I plus 1, and that's going to be the gap after the current event. Then we're going to say let best left equal I equal 0 question mark -1 colon prefs square bracket I minus 1, and that's the max gap before the current event. So if I does equal 0, right, this right here, this equal sign is going to return a Boolean, true or false. So if I equals 0 is true, it's going to return -1. If I equals 0 is false, it's going to return prefs I minus 1. Then we're going to say, do the same thing for right. We're going to say let it's going to be best right equal I equals n. So if I equals n is true, we're going to say question mark. If that is true, we're going to return, or excuse me, if I equals n minus 1. If that's true, then we're going to say question mark. And if that's true, we're going to return -1. Then we're going to say colon. If it's not true, we're going to return suffs square bracket I plus 1. Boom. Just like that. Now, and that's the max gap after the current event. Now we need to merge the current left and right gaps by declaring a variable called time. We're going to set that equal to L gap plus R gap. Boom. Then if the event slot can fit in another large enough gap, we're going to add its duration. So we're going to say, come underneath this, and we're going to say if best left is greater than or equal to slot or two or signs, two vertical lines for or, best right is greater than or equal to slot. Then we're going to open up the brackets. We're going to say time plus equals slot. And then we're going to track the maximum free time window by coming underneath this and saying ands equals max, open up the parentheses, ands comma time. So whichever one is larger, and this max right here is going to return whichever one is larger, ands or time. And then it's going to set that equal to ands, and then all we have to do is come right here and say return ands. Boom. Just like that, y'all. Let's give it a run before we submit it. Make sure it works. Let's see. Okay, cannot find start and scope. So sorry, y'all. This should be start time square bracket 0. So we're gonna just put the time in right there. Run it again. Let's see, and that's accepted. That's what I'm talking about. Let's go ahead and submit it, y'all. Let's see. 4 milliseconds beats. I don't know what this dash is. I guess 100% of solutions had the same runtime. I guess I don't know what this dash means, but 4 milliseconds, y'all. It's accepted. That's what I'm talking about. Those are some good numbers right there, I guess, y'all. And with that being said, let's make sure you get one more look at the code. This is the top part of the code. This is the bottom part or the middle part of the code. It's the middle part of the code. and boom, this is the bottom part of the code. And with all that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.